Imagine waking up one morning. You go through your usual routine, perhaps making a cup of coffee, glancing out the window, expecting the familiar morning light. But today, something is profoundly wrong. The sky is not brightening, it remains as dark as the deepest midnight, studded with distant, unblinking stars. There was no explosion, there was no warning. The sun has simply vanished. Would we even notice its absence immediately? Would the Earth instantly freeze over, plunging into an eternal winter? Subscribe to Doubts Undertaker if you enjoy clear answers to impossible questions. Imagine the moment our sun, the very heart of our solar system, simply ceases to exist. The most immediate and obvious consequence would be the onset of a total, permanent darkness. However, this profound change would not be instantaneous. There's a built-in delay, a final message from our star already on its way across the void. The light that warms our skin, powers our ecosystems, and illuminates our world has to travel an immense distance to reach us. That journey spans approximately 150 million kilometers, a gulf of empty space so vast it's difficult to truly comprehend. Every single photon, every particle of light that reaches your eye from the sun has completed this epic voyage. Light, while incredibly fast, is not instantaneous. It journeys through the vacuum of space at a staggering constant velocity of nearly 300,000 kilometers per second. This is the universe's ultimate speed limit, a fundamental constant of physics that nothing with mass can ever reach. To calculate how long this journey takes, we perform a simple but mind-bending calculation. Divide the distance by the speed. 150 million kilometers divided by 300,000 kilometers per second. The result is 500 seconds. Even at this incredible, unmatched speed, it takes approximately 8 minutes and 20 seconds for a photon of light to travel from the surface of the sun to our planet. This cosmic delay means that for 8 precious minutes and 20 seconds after the sun has actually vanished, we would remain blissfully unaware. We would be living on borrowed time, bathed in the light of a star that no longer exists. It's a concept known as our light cone. We can only perceive events after the light from them has had time to reach us. In this scenario, the sun's demise would be an event outside our immediate cone of perception. During this strange 8-minute grace period, life on Earth would continue completely as usual. The sky would remain blue, the clouds would drift by, and the sun's warmth would still be felt. No instrument, no matter how sensitive, would detect that anything was wrong. The final photons from the sun's last moment of existence would still be arriving, carrying the illusion of normalcy. Then, suddenly, and without any warning, the end of that delay would arrive. The last photon from the living sun would strike the Earth. One moment, the world is lit. The next, it is plunged into a darkness more complete and profound than any night ever experienced. It wouldn't be a fade, it would be a switch. Instantaneous, absolute blackness. The familiar celestial bodies we see by reflected sunlight would also vanish. The moon, our constant companion, would disappear from sight, as its only source of illumination would be gone. The planets, like Venus and Jupiter, which often shine so brightly in our night sky, would become invisible. They would still be there, of course, but now just cold, dark spheres drifting in the black. The only light remaining would be the faint, cold twinkle of distant stars, suns so far away, their light has taken years, or even millennia to reach us. And on the ground, the artificial glow of our cities, which would suddenly become the brightest things in our world, lonely islands of light in an ocean of unending night. But light is only half the story. The sun doesn't just hold us in its light, it holds us in its gravity. For the same reason that light continues to arrive for 8 minutes and 20 seconds, Earth would continue to follow its familiar orbital path. For those 8 minutes, our planet would remain tethered to a ghost, moving at a breathtaking velocity of approximately 30 kilometers per second, utterly oblivious that its gravitational anchor has disappeared. This is because gravity, like light, has a speed. It is not an instantaneous magical force. According to Einstein's theory of general relativity, gravity is the curvature of space-time caused by mass. When the sun vanishes, it creates a disturbance in this fabric, a ripple that propagates outward. And how fast does this gravitational ripple travel? At the exact same speed as light. So at the precise moment the last photon strikes Earth and the lights go out, the last gravitational wave also arrives. The darkness and the release from orbit would happen at the exact same time. This raises a deeper question. What happens next, when Earth is suddenly untethered, flying off into the cold, dark void of interstellar space? To understand why we wouldn't know about the sun's disappearance for 8 minutes, we must move beyond our everyday intuition about gravity. For centuries, we pictured gravity as an invisible rope, an instantaneous force pulling objects toward each other, just as Isaac Newton described. But this idea of spooky action at a distance deeply troubled Albert Einstein. His revolutionary insight was that gravity isn't a force at all. Instead, he reimagined it as an intrinsic property of the universe itself, a curvature in the very fabric of space-time. Imagine space-time as a vast, flexible sheet. A massive object like our sun acts like a heavy bowling ball placed in the center, creating a deep depression. Planets like Earth aren't being pulled by the sun directly. They are like marbles rolling along the curved path created by the sun's immense mass. They are simply following the straightest possible line through a curved, four-dimensional reality. This elegant and mind-bending concept is the very essence of Einstein's theory of general relativity. This new picture of gravity solves the puzzle of our 8-minute delay. If the sun were to suddenly vanish, the deep well it creates in the space-time fabric would not instantly flatten out. The information that the mass is gone must travel. The change would propagate outward from the source, not instantaneously, but at a finite speed, much like ripples spreading across the surface of a pond after a stone is removed. These ripples in spacetime are known as gravitational waves. They are disturbances, literally stretching and squeezing the space they pass through, carrying energy and information about their cataclysmic origins, such as the collision of black holes or the disappearance of a star. Einstein predicted that these waves must travel at the ultimate cosmic speed limit, the speed of light. This means the speed of gravity is the same as the speed of light. For a century, this was only a theory. But in 2015, the LIGO experiment made history by directly detecting these faint tremors from a distant cosmic collision, confirming Einstein's prediction in one of the most profound discoveries of our time. So, as the last photons from the sun complete their journey to Earth, the final gravitational waves generated by its presence would be arriving right alongside them. Once that final ripple of the sun's gravity passes us by, the space-time around our planet will become flat. The cosmic tether will be cut. Earth's trajectory and its destiny will be forever altered as it continues in a straight line into the void. It is now a rogue planet, cast adrift in the cold, dark expanse of the Milky Way. Without the sun's constant stream of energy, our planet's primary heat source is gone. The planet will now begin to shed its stored heat into the freezing vacuum of space. The average surface temperature of our planet is a comfortable 15 degrees Celsius. By the end of the first week, the global average temperature would have plummeted to approximately minus 17 degrees Celsius. After one full year of drifting through the dark, the models predict that Earth's average surface temperature would reach a staggering minus 73 degrees Celsius. How long before oceans freeze? The surface would ice over within weeks, but the immense heat stored in the deep would mean a complete freeze would take thousands of years. Would volcanoes keep us warm? Geothermal heat from the Earth's core would persist, creating small, localized hotspots, but it's not nearly enough to warm the planet. If this surprises you, like the video and share it with someone who loves science. The moment the light goes out, photosynthesis stops instantly, everywhere. This isn't a slow decline, it's a planetary switch being flipped. For the vast majority of life, this is the start of a planet-wide extinction event, a catastrophic and irreversible collapse of the food chain. Small plants and the ocean's vital phytoplankton, the twin engines of our biosphere, would be the first to perish, their life-giving processes ceasing within days. Without this foundational layer, the intricate web of life begins to unravel with terrifying speed. Herbivores, deprived of their food source, would starve soon after, their desperate search for sustenance ending in a matter of weeks. This wave of death would then climb the food chain, reaching the carnivores who depend on them. In the span of a few months, the world's ecosystems, built over millions of years, would be reduced to silence. Surprisingly, one crucial element would persist long after the biosphere has collapsed. The vast reservoir of oxygen in our atmosphere, a legacy of eons of photosynthesis, wouldn't vanish overnight. Models suggest it would remain breathable for thousands of years. It's a tragic irony, a planet rich with the very gas that signifies life, but with no complex life left on its surface to breathe it. The air would remain a ghostly reminder of a vibrant past, a silent testament to a world that was, while the surface temperature continues its relentless plunge toward absolute zero. Humanity's only hope for long-term survival would be a great retreat, a migration not across continents, but deep into the Earth's crust. We would have to construct self-sustaining habitats, shielded from the lethal cold of the surface. These subterranean arcs would rely on the planet's own internal heat through geothermal energy, or the immense power locked within the atom through nuclear fission. Could humanity survive in such conditions? For how long? Our existence would become a fragile, constrained life in a bottle, a technological struggle against entropy. Generations would be born, and would die having never seen the sun or felt the wind, forever dreaming of the sunlit world that was lost, a world known only through stories and data logs. As our planet journeys away from its dead star, it officially becomes a rogue planet. Its long-term cosmic outcome is to drift aimlessly through the interstellar medium, a lonely wanderer in the cosmic dark. No longer tethered to a gravitational anchor, Earth is now subject only to the faint, distant pulls of other stars and the galaxy itself. Its path is a near straight line through the void, an endless pilgrimage into the unknown. What are the chances it might find a new home? Could it be captured by another star, offering a distant future generation a new dawn? Astrophysics simulations show that the odds are astronomically small, the distances between stars are simply too vast, and the gravitational wells too shallow from afar. While our rogue Earth might occasionally pass another star system, a close encounter would be more likely to result in a gravitational slingshot, merely altering its course and flinging it back into the darkness, rather than a stable capture. For every one planet that might find a new stellar parent, countless millions are destined to wander forever. Even the Earth's own internal furnace cannot burn forever. Over billions of years, the geothermal heat that might have sustained humanity's last remnants will inevitably fade. The radioactive decay in the core will slow, and the planet's residual warmth will radiate away into the void. The planet will slowly approach thermal equilibrium with the near absolute zero of deep space. Any underground oceans will freeze solid, and the very rock of the mantle will become brittle and inert. Ultimately, Earth becomes an inert, frozen sphere of rock and ice. It is a silent monument to the vibrant, living world it once was, carrying the frozen fossils of a long-dead civilization on an endless, solitary journey through the galaxy. A cosmic tombstone, forever preserving the evidence that, for a brief moment in eternity, on this particular rock, there was life. Our journey through this hypothetical catastrophe brings us to a profound and undeniable truth. The sun is not merely a bright object in our sky, it is the fundamental pillar upon which our entire existence is built. This thought experiment starkly reveals the intricate and delicate interconnection between light, gravity, and biology. Every aspect of our world, from the air we breathe to the warmth we feel, is a gift from the sun. The daily sunrise is not a mundane event, it is the continuation of a 4.5 billion-year-old partnership that makes everything we know and love possible. The sun isn't just a star, it's the reason Earth exists as home. Subscribe to Doubts Undertaker, comment what question we should bury next, and share this video to continue exploring the biggest questions in the universe.